So we have a number of questions in the Q&A box, and a couple of them were actually questions that I had. So I'm going to kind of jump around and start with the ones that were on my mind that someone else asked as well. And the first one is more of a statement, but it is a question, and is that my impression was that higher strength concrete and steel grade with reduced section size and rebar quantity would reduce embodied carbon. And I had the exact same thought. I mean, what you were describing really seems to kind of go opposite of what I have heard or what I thought to be true.
Yeah, in terms of actually using lower strength concrete.
Yeah.
Yeah, so that is also that is was my assumption going into learning about this topic as well. And actually, like, when we start talking to, say, leaders of Thornton Tomasetti about this, and say we want to start reducing embodied carbon, they say, don't we already optimize in our structural design for the smallest member possible? I think the insight is just how different the sort of unit cost of embodied carbon is with these different strengths. And say normal weight versus lightweight, it's not changing by 5 or 10%. It's changing by 40%. So those things, the mix itself, either going lower strength or higher cement replacement, tends to really have an outsized impact, even more than smaller sizes.
There was another question, and it kind of relates to the same subject, and it deals with ultra high performance concrete. Any consideration using ultra high performance concrete with high SCM replacements, such as 60%, to enable reduction of cross-sectional dimensions of columns for high-rise buildings?
Yeah, I have heard of this, Patrick, again. I have definitely think that this is a really viable option for high rises, both in columns and, say, shear walls, because you need that high strength to make these things work. And again, we're not trying to give, say that you should always use 4,000 psi concrete in a 30-story building. That's just not going to be possible. So, and actually, there's a lot of benefit when you have those really high strengths with also having high SCMs. So yes, I have seen that definitely, high use of SCMs with high strength concrete, particularly in high rises. I think it's a good solution.
Looking at a project in Chicago right now that's going to be ultra high rise, that's 70 to 80% fly ash, just to give an example.
It's ultra high performance concrete with 78% fly ash?
Yep. Mm-hmm.
Another one question here is, I guess it's to Thornton Tomasetti in general. Do you take embodied carbon reduction into account when designing all of your structures, or is it client driven?
Excellent question. Like Emma said, it's new, right? We only have had a handful of projects where the client has come to us and said, we want to reduce embodied carbon. So it's really the last couple of years that we've really gotten our expertise in this. But what's interesting is what we're finding is how many of these strategies we could apply on our own to most buildings. And at worst, we could just take it to any owner and say, listen, we have this metric embodied carbon. We could make these couple of adjustments and get some big savings, or we could not. It's up to you as the owner. So right now, it is definitely not all of our buildings, although we're doing some interesting things at TT, like tracking the embodied carbon of a huge range of our projects, just to see how we're doing on average and have some benchmarks to compare it to, which is another tough thing, is just getting the right benchmark, right? Because it's not like we've been measuring embodied carbon for 30 years and we know what a building should be. So
what percentage of your projects do you think you are actually taking these steps on? 10% or 20%?
Emma, what do you think about measuring it? I would say in terms of like an involved owner who has a target, it's smaller than 10% right now.
Yeah, we have We have, done carbon accounting for over 600 projects, though, internally. This project has been going on for 8 years at TT, and we've been contributing this data to the MIT and Carbon Leadership Forum's database for embodied carbon benchmarking, which is right now the only only way to benchmark your building against embodied carbon. It's through firms like us contributing this data on an annual basis. I will add that I mentioned this really briefly, but the Structural Engineers 2050 commitment, which the detailed guidelines are coming out later this fall, will require reductions in embodied carbon, and we are part of developing those guidelines for our firm and for other firms like us to commit to and advance this design. We're also sort of actively looking for architectural and owner partners to teach them about embodied carbon and walk them through what it takes to get include this in as a performance metric at a lower cost. So it's a priority for us, but it's not something that has been in every project.
And just to add, like we're definitely at the beginning of this as an industry, and so for suppliers and engineers on the call, there is an opportunity for all of us to be sort of seen as leaders in this, to be the supplier who can go around to clients and say, hey, we know how to do this. And what we found is owners are receptive. They just need to know about it. And often they don't know about it yet. So part of it is just educating the market about it.
So that was another question I had, was on the 2050 initiatives, the Structural Engineering 2050. I mean, it seems to me an important component of that is going to be going upstream to the universities that are training these engineers and getting this information into that curriculum. And I guess the first question is that part of the overall strategy for Structural Engineering 2050? And what specifically are you doing to try to change how structural engineers are trained?
That is actually part of the initiative. I can't go into detail on this call, unfortunately, but we'll be able to provide more details in a couple of months.
I got more questions here, but Terry, do you have one or anything? I don't want to just occupy here, but there's a number more here to go through.
Yeah, I think there's a number in there, and there's two that are in the chat, so we should probably get to those. I have a million questions, so don't let me have it, or we'll never get through.
Okay, so let's let me read this. Portland limestone cement is being marketed as an easily achievable reduction in embodied carbon, but it wasn't mentioned in the presentation. Does anyone have any experience using this or specifying it in their projects?
Is that a no?
Yes.
Sounds like a no.
Sorry, no, I haven't used it specifically in a project, and it very well could be. I mean, so I'm coming from the engineering side, so my knowledge of the new types of cement might not be as good as on the supplier side, but certainly, I mean, these types of things in terms of different types of cement are the big game changers for using them in the future. So it very well could be. I just have not used it on a project.
Or you didn't know it, one of the two.
Right.
When determining the reduction, do you have to do two designs for your clients? If you just did best practices and optimizing, wouldn't that save more money for your clients?
Yeah. So this depends. It depends on the client and what the client is asking. So like I said, there are situations where you may just take it on yourself as an engineer to try to address this in your design, just always be cognizant of it. Or there's an owner who has a specific target, in which case, in terms of doing two designs, I would say it's very similar to what you would normally do in concept design, where we might bring a couple of different ways of framing a typical bay to the architect or the owner and say, well, this one's a little bit less steel, this one gets you a little more clearance. So it's just the same thing, except this one has a little more embodied carbon. than this one. We're certainly not doing 2 designs of the whole building and then giving them an option. It's really early and broad decisions. And then once you get into, say, designing a footing, normally what I'll do is, as you're designing the first couple of footings, you do this check of, well, if I change this concrete strength and increase the size, what's that get me? And that will kind of guide you for the rest of it. It's not by any means a significant add to your engineering time, I've found in going through projects. It's a pretty quick check with kind of big payoff. So.
For reducing embodied carbon of concrete structures, one solution discussed was to increase the thickness of the slab and reduce the cement content and concrete grade. So in practice, have you experienced a pushback from the AOR or ownership on this suggestion?
Yeah, so in practice, the times when we've done something like this are the projects that have the specific reduction goals. So everybody is kind of on board with trying to do that. But yes, there are certainly some of the things I showed, like increasing that slab thickness, where if you bring this up, say in DD, and embodied carbon is not a sort of stated client goal, yeah, it's not going to go over well with the architect. So things like that's why you have to, same thing as this cement replacements, you have to consider this on an element by element basis. Will anyone notice if you make the footings 2 inches thicker? Probably not. Everybody's going to notice if you make the slab 2 inches thicker. So that will definitely vary about how committed or what targets the architect or the owner has for that project. And you'll have to make different decisions based on the project.
I can add that in terms of slab design, in terms of strength, obviously beam column connections and requirement to puddle when your column strength is much higher than that of the slab strength, those conditions would be a lot more prevalent with lower strength slab mixes. And in many cases, we increase the strength of the slab such that we can avoid, puddling around the beam column connections. So
that's a great example of like knowing that on the engineering side will be important to making the right decision, right? I mean, if I have 6,000 psi columns and I say it's a 4,000 psi slab, if I don't know that, and then on the supplier side they say, well, it just makes more sense to us to do 6,000 psi slabs, I haven't really done anything then. So that type of information is great for engineers to know from the suppliers.
So you really didn't touch at all on durability. We had a question on durability, that a combination of good design and detailing and concrete protection methods can go a long way in a sustainable environment by reducing the need for repairs and minimizing the usage of natural resources in the future. The individuals just wondered what your thoughts were on this. And I guess I would maybe just rephrase the question as, from your perspective, what is the role of durability and the role of designing so that there is low maintenance in the future?
I think right now, the way that buildings, calculate their embodied carbon, it's really more of the cradle to gate side, because we don't necessarily have control of what the owner sort of does to the building after we've built it, But there is, some upcoming research kind of detailing like, oh, if this, is going to be fine for 30 years versus 50 years, and what the volume of repairs, the concrete of that repair volume might be. That is something that can be, taken into consideration here. But the way the methodology is right now, it's more limited based on the scope we have.
But yeah, I would say it's a harder to quantify but equally important thing. I mean, like, I think Kurt mentioned this early in his presentation. Just repairing existing structures and getting the technology and analysis right to do that could be just as more impactful than being good at reducing it on new buildings, because you're saving an entire new building by being good at reusing existing building stock. So it's harder to quantify, and that may even be an earlier than concept design decision. That's more about, I guess, making owners and early stakeholders aware of, that this could be something to consider when deciding whether to, say, knock down a building or build a new one or renovate an existing building.
Well, I don't want to take food off of Kurt's table, but I mean, if you can design it in the beginning so that the repairs aren't needed, isn't there a sustainability gain there?
Yeah, I mean, this is Kurt. I would definitely say you want to have durability in mind from a design perspective. If you're talking about total life cycle costs and implications from an environmental perspective, it's always, I think it's always better to build it for longer and to avoid repairs. Some things you can't do that because you have a complete change of use, right? So
Sure.
if your plaza was once just for pedestrian traffic and now has to hold, big water detention ponds, then you're going to have a big change of use. So some things can be avoided that way, but certainly from a durability, from a corrosion perspective, all of those things should be considered on the design side to reduce cost and reduce waste later on.
I'll add. Just one thing that, so we didn't really talk about things besides structure, but we do these embodied carbon calculations on things like facades as well. And there, part of the calculation is, what is the lifespan of this facade? Is it going to last 50 years versus 30 years? So something that may seem like it has higher, say, carbon initially, like a concrete facade, but that is going to last for much longer, could end up coming out kind of on top when comparing two different facades.
I might add that it seems when we talk about durability, the old school yardstick for that was water cement ratio. And I think it's a lot more detailed conversation than that today. And Larry, I know you've got a team of people doing a lot of work to try to define, the durability aspects. And I think that will reduce embodied carbon when we look at durability subject in more detail.
Kind of related to durability and also related to your some of your solutions, which you presented. One person asked about recognizing other materials than fly ash. Fly ash will be a premium product in the near future. Slag and metakaolin are only available in certain areas, at least from a cost beneficial basis. So it is kind of a larger question that if reduced clinker factor is really what you're going for in terms of the concrete mix, and if these other materials aren't available, fly ash, slag, then what?
It's a good question, and that's I think whereas things like these methods here are probably the most important thing today, I think that is the most important question going forward. So is how are we going to address this when we don't have these products available? There's a lot of good research going on. I don't think we have the answer yet. The other possibility is that section I mentioned with carbon sequestration, like having aggregate that's captured carbon being put in, you could potentially, if say you don't have cement replacements, use your full cement, but you're storing so much carbon in the concrete that it more than offsets it. That's a possibility too, going forward, in terms of like on an economy-wide scale.
If you didn't, go ahead. I'm sorry.
Oh, okay. There's also understanding that, the grid is slowly greening little by little. So those, the fossil fuels that have been used to superheat, the limestone and make the cement, are being phased out in many areas, which will, lead to a lower overall, embodied carbon reduction. I think something that I just like to talk about when asked, that question is that this issue is sort of here. It's now. We have 10 years to really cut this carbon in half to if we want to do something about climate change. So we should be focusing on this low-hanging fruit that's available to us this year, in the next 5 years, and then continue to pursue a lot of these alternative methods after that. But we really want to focus on what people can do now, and those technologies are pretty readily available at low cost at this time.
I'm trying to read this question here. Hang on a second.
Larry, or this is Kurt. Can I just jump in on one of the? I know one of the things that's being researched is trying to actually recover fly ash from landfills to be used potentially in concrete. And so I don't know at what stage that research is. I think it's maybe just now starting, but that's sort of one thing that's out there. But I think that the long-term outlook for fly ash is probably not going to be there in the next, I don't know how many years, but it's something that I think the industry is recognizing and slowly working towards.
Yeah, that's a whole nother hour-long conversation.
Absolutely.
I don't think it's as dire as we think it is, but I think in certain markets there's going to be issues. But the harvested ash is certainly going to be a factor in the future, and I don't think fly ash is going away quite as fast as maybe people think it is. But the quality could be changing. And a lot of other things that make it a little more difficult to work with. So someone asked a question here, and I guess I'll just read it verbatim because I'm not 100% sure. Well, let's just see. Hopefully policymakers do not pass laws setting required reductions. Then the previous question could lead to shady practices to show artificial reductions, much like retailers raising prices before a sale to show a savings. So I think I understand that what they're really talking about is this whole idea of the two design idea and showing the reduction is that, would a designer then do the initial design with a high carbon and then do a standard design to show a reduction, and in the end, nothing was accomplished. I think that's what's being asked.
Yeah, I think it's an important point that any legislation, and we kind of had this discussion with NTT about supporting the New York law. We kind of read it carefully and things like that, because right, depending on how you word it, you could end up not achieving what you want to achieve. Benchmarking is a particularly tough thing, like I said. Yes, it's a 30% reduction from what? So, the studies I gave were from a specific type of system, but it's very hard to capture that kind of thing in legislation. So the one in New York is about giving a competitive advantage in bids to the concrete supplier that can say, my mix has this much embodied carbon per yard versus these. So I don't know the exact right answer, but I do think that comparing to a benchmark is probably not the right answer. It's something like, you have a certified EPD, an environmental product declaration, and it has a value, 300 kilograms of concrete per cubic yard. And it's that type of thing that's the standard. Like either yards of concrete have to meet a certain level, or buildings as a whole have to meet a certain level. I think I agree with I think what this is getting at, that mandating a percent reduction is particularly tough to do in a smart way, I think, from a legislative perspective.
I'll add for just this disclosure documentation that Patrick's referencing, the environmental product declarations, which tells you how much embodied carbon you have in your product. If these are required to be third-party verified, for to be recognized by LEED and to be, recognized in this potential bill. So it's not like the manufacturer or supplier can just report something out. There has to have an external body come in and verify that data, and I think that's something that we would support. Just to make sure that we're not showing false reductions, basically.
Yeah, I think if I understood the question, they weren't really thinking so much along the lines of the EPD, and the materials per se, but more along the lines of the design. You're making a design change, even if you use the same cement. I mean, it's the EPD is
Yes.
the same. So you're making a design change, and who says that the first design wasn't already inflated?
Yeah. The design side is really difficult to. It's really powerful. Like I showed, like those design decisions have a big impact, but yeah, in terms of tracking what you actually did during the design, either from a legislative standpoint or even a, say, project reduction goal standpoint, it's fairly tricky. So I think, and for instance, like I could have designed a building that uses 4,000 psi concrete instead of 6,000, and there's nothing weird at all. There's no high cement replacement to my 4,000. So it doesn't look like I've made some big reduction, but I really did on the design side just by lowering the concrete strength. So I think it's an important note, and I don't know exactly what the right answer is to try to quantify that, except making kind of all structural engineers aware of this and be tracking it during their design.
Yeah, I was gonna say,
honestly,
go ahead.
Honestly, we're playing around with that as well. Like in the specs that we're writing, we have both metrics. We have an embodied carbon target value per square foot that's based off of this benchmarking data that the Carbon Leadership Forum is collecting, and is really the only data that is out there right now for the industry, that tells you what a good performing quote unquote building per square foot could be versus a poor performing by typology. But we also have the percentage reduction, because there isn't right now a clear sort of market driver right now towards one or the other, because both have their problems. So that's something I think the industry is trying to figure out for sure. But
Emma, do you do that on all projects, or just when a client asks about embodied carbon? Are you looking at embodied carbon on all of your projects, or just those that your client says, yeah, we want to look at that?
We're mapping embodied carbon on all of our projects. We're accounting for all of them on all of our structures projects, so over 600 projects, and taking the extra step, like what Patrick's work has been doing, when it's a client goal, or when we have that available capability in-house to do that work.
Seems that a single-use building would be a lot easier to apply these embodied carbon per square foot. But most buildings today are multi-use. You start with a parking garage, you have a podium deck, retail for a couple floors, office, and then condos on the top. So the structural requirements change, dramatically on the use of the building. So, if you put a pool on the 20th floor, you're going to have a lot more embedded carbon in that structure, right? So I think that those square foot measures are good, but in a way, if you legislate certain minimums, it really will dictate how structures are, what structures can have in them and how they're used.
What, if you had to make a guess, or maybe but if you had to make a guess, what percentage of your projects where you have accomplished carbon reduction, what percentage of those projects are lower costs than if you had used the other design?
That's a good question. I would say in all of the ones that I either are mine or are or that I know of that TT has done, I think the word I'll use is little to no cost change. I wouldn't say we're making them particularly cheaper or more expensive, because most of what we've done has been using the kind of schemes I've laid out about, and at least right now, the cement replacements aren't, appreciably, say, more expensive than cement, at least in the markets where we've used them. I know it varies a little bit by market, but I would say that most of these strategies are roughly cost neutral. I mean, it's hard to track, right? Because if you do something like select a really small grid to do this, it's hard to compare that and say whether it's probably less expensive, but there are a lot of factors that go into it. Most of these that have specific reduction goals, I haven't seen one that has a metric of like, what would the building have been without these goals, and to do a cost comparison. But I would say that the specific strategies we use don't have huge cost implications.
Larry, I have a couple of questions that I
Sure.
think we've asked all of the ones that were on the list.
Yep.
So this is really for Patrick and Emma. One easy thing to do would be to have specifications or concrete requirements that made sense. And I'm trying not to be offensive here to engineers, but when you see a specification
Don't
that
worry
requires, it's really hard for me sometimes. But when you see a specification that you see and it says, this is in Atlanta, Georgia, and they want 10,000 PSI concrete for columns for a parking structure, and they want it air and trained at 4 to 7%. That makes no sense, right? I mean, it's Atlanta, so it's not really a freestyle issue. It's vertical concrete. It's never going to be saturated. Plus, it's 10,000 PSI. You're not going to have freestyle. And so what happens is, because those mixes are difficult to make, difficult to produce, difficult to manage, you end up throwing away a lot of concrete, which is a waste, right? I mean, that's a lot of wasted cement. So for a 50-yard placement, you might actually batch 80 because your air is very difficult to control. And I talk to a lot of engineers with ready-mix suppliers trying to get those types of things changed. And invariably, it's like a 200 batting average. We're not very successful because, that's the spec, you bid it that way, you got to live with it. So how do we change that mindset of, concrete specifications that, pardon me for saying so, just don't make sense?
Yeah, no, I think it's a really good point. And I think that disconnect in knowledge between what the suppliers know and what the engineers know is probably our biggest problem to making these reductions. So, one of the first things we did when we started getting a couple of these jobs with targets to reduce was get on the phone with our 2 or 3 biggest suppliers in the area and just talked about things like this. And that is the way this stuff happens, but you can't, the way to make that happen, if the engineer is not the one proactively doing it, or the supplier doesn't have some way of reaching out to them on a specific project, I don't know what the answer is. Obviously, it's, the answer is education, right? The engineers need to know these things that the suppliers know. But the best avenue for that, I mean, honestly, things like this, things like what ACI does is pretty important in that. But I don't know what the I don't have a silver bullet for that, for getting that knowledge better between these two groups, because I think there's a disconnect. I think there aren't a lot of periods in the project when both of these people are heavily involved, and that's the problem. The engineer finishes at CDs, yes, he's still involved in CA and RFIs, but yeah, they don't want to change anything about the building at that point. I mean, they're winding down when the suppliers are trying to get these things changed. So it obviously has to happen earlier, but I don't know what the right kind of avenue is for that communication.
So a follow-up question, and I'll make a comment first, is that Brad Momstein and Patrick with Central Concrete and myself, we're setting up a call between engineers, specifiers, and a group of ready-mix folk that's going to happen in the next couple of weeks to kind of talk about how there can be more interaction between the ready-mix folks and the specifiers. So that'll be interesting. So that we're working on getting that set up. But my follow-up to that is, you know, an engineer looking at things like this and says, you know, he's interested in being green, doing something different, and you bring them a solution, and the response is often, you know, I'm not comfortable with that. It's too new. And by too new, I mean it's not, you know, 20 years old, right? You know, it's like you mentioned limestone cements being new. They're not new. They're new to you. So what does a engineer need to see to be comfortable using something that's new to them? What do they need to see? And I know you can't speak for everyone.
Yeah, I can't speak for everyone, and I know some people it will be a lot harder to convince. You know, things like precedent projects, obviously, but and testing data. But I think a lot of that onus is on the engineer side. We need to be better at you know, not exactly what you said, not using new technology that's you know 20 or 30 years old. The construction industry as a whole is not good at innovating quickly, and we need to get better at this. And engineers.
Totally agree with that statement. Yeah,
Yep.
Totally. Yep.
And we are still learning how to use products that have been around for many, many years. Another example was mass concrete, where we require 28-day design strength. It really defeats the purpose of trying to keep the heat down. But I have 2 jobs going on right now that have mass concrete 7 to 12 feet thick that I have to meet strength in 28 days on. So there's a lot of examples like that where I think we can reduce the amount of cement used and not affect the projects at all. And in this case, even improve the project quality.
Yeah, everyone in the construction industry, I mean, it's not just specifiers, it's not just contractors. You know, the material suppliers, they're fairly slow to adapt as well, ready mix guys. So, you know, there just needs to be a better way to take things that are really new and prove them, use them. And it's not all about being green. There's other efficiencies that go with that. But we're just slow. We're slow to adopt.
So there is a comment in the chat about ACI building codes need to be updated to encourage new materials. And you go on to say that PLCs with 20-30% class F ash have been used for pavements in Colorado since 2006. So I would just make a comment on that, as I agree first, but also there has been some movement. And so, you know, in the latest edition 318, it does allow for alternative cements. It does allow for 1157 cements. So I think there is movement that way, but, you know, kind of to the last point, it's just a slow process, and everyone's different. For me, a lot of it comes back to what I asked earlier about is the education. We need to educate engineers coming out as to what some of these alternatives are. So I believe we've reached the end of our time, and I would certainly like to thank all of our presenters for great presentations and for a great discussion afterwards. Very good questions from the audience. I think this has been a very good session, and appreciate you all taking the time to join us.